Well, hello scrappers. Mike here. Welcome back to my channel and welcome to part 2 of a series I am calling Forbidden Chemistry, or how to make the stuff you can't buy. So just to recap, back in part 1 I talked about how I get a lot of comments on my videos from people all over the world who say, "Oh, I love what you're doing. I'd like to do it myself, but I can't buy potassium nitrate or other nitrate salts." Or, "I'd love to do it, but I can't buy concentrated sulfuric acid." Or, "I can't buy nitric acid." You know, in their country, they can't buy it. It's illegal to sell it. It's illegal to buy it. Some places it's illegal to possess this stuff. So be very careful before you emulate what I'm doing in this video to familiarize yourself with the laws of your country and make sure it is not illegal to actually possess this stuff or manufacture it for your own use. You could get into trouble if you don't do your due diligence. I don't want you trying to blame me. But if you can't buy this stuff and you're allowed to possess it, I'll show you how to make it. Now, back in the first video, I showed you how to make potassium nitrate from easily sourced common chemicals. And it was fairly simple. And we made some potassium nitrate, tested it out, works great. So this would come in handy for making poor man's AR. But what we're going to use it for, what we're building up to in this series, is making nitric acid with it. Concentrated nitric acid. But we need another ingredient before we can get to nitric acid. We need concentrated sulfuric acid. And that is just not available in a lot of places. It's pretty simple to make. Now, that being said, I was last night reviewing the laws in the EU. So if you're watching this in the EU, be careful, okay? Because the way I'm interpreting the law, it's even illegal to just possess concentrated nitric acid, okay? Now, I don't know about a lot of other countries. I did a little bit of research on Australia, a little bit of research on Canada. In a lot of the Commonwealth countries, you're not allowed to buy or sell concentrated sulfuric acid to somebody without a license. So, but I can't get into the intricacies of the laws in every country and every region. So you got to do your own due diligence. But if you need some for your own uses, I can show you how to make it. And there's several different ways you can do it. All right. Now, first off, make sure it's not actually already available to you. Okay. This is a drain opener or drain cleaner, as they sell it here in the U.S. And this is about 95 to 98% concentrated sulfuric acid, with a few inhibitors added to prevent it from dissolving your metal pipes. So this works great for making nitric acid and just about anything else I need concentrated sulfuric acid for. It may be hard to get in your country, but maybe it's not impossible. So look around first. Maybe in specialty shops. Maybe you need to know a plumber. But look around. Maybe you can get it without having to make it. But if you got to make it, well, there's a couple of possibilities for what we can do. I mean, every country has cars with gasoline engines and lead acid batteries, right? Yeah. I mean, we still got them. So as long as there's gasoline engines with lead acid batteries, starter batteries, then there's a way to obtain sulfuric acid for batteries. Okay, in your country somehow you can obtain it. Auto parts stores, specialty stores, whatever. I don't know. Some places you may need a license to get it. Some places you may have to buy a battery to get it, but there's probably ways around that, though I'm not encouraging breaking the law. But usually there's ways around anything. So they'll sell you acid for your batteries. You not just your car. If you've got like a solar power setup and you have a battery bank, you need acid, okay? So if you're dealing with lead acid batteries, you need sulfuric acid. So you should be able to buy sulfuric acid in some form just about anywhere. I mean, even in the EU, you should be able to get this, or their watered down 15% acid that they'll let people have. This is what we're going to start with for this video. okay, to make our concentrated sulfuric acid. Now, this is about 35% sulfuric acid, and we're going to concentrate this up to close to 100%. Maybe we can get up to like 95%. We'll see. Um, so that's what we're going to start with. Now, as long as there are gasoline engine cars that need lead acid starter batteries, you're going to be able to buy this. When we all go electric, and then the cars only have lithium-ion batteries in them, well, I guess you folks in the EU and Commonwealth countries are just well and truly screwed, because basically this stuff will probably become impossible to find. And I suppose the nanny staters here in the U.S. will be looking for an excuse to ban us from buying it too eventually. But for now, this is what we're going to start with. But if for some reason you can't get this now or in the future, there are other ways to manufacture sulfuric acid. And in future videos, we may explore some of those ways. Okay, something like electrolysis of a copper sulfate solution to produce copper and dilute sulfuric acid, which then we can, once we have dilute sulfuric acid, we can concentrate it up as strong as we want using the same method I'm going to show you today. So there are ways, there's always going to be ways, okay? The nanny staters and the know-nothing politicians can ban things all day, but there's anybody with a little bit of knowledge of chemistry, knowledge of the real world, which politicians generally don't have because they only come in two types. People who have never had a real job and lawyers. Those are basically your two types of politicians. The wrong kind of people to be leading us, in my opinion. I try to steer clear of politics, but I had to have a little rant there. But anyway, there's always going to be a way, no matter what government says. Just don't get yourself in trouble and break the law. Okay, so let's figure out how we're going to concentrate this stuff up to 95%. All right, a couple of things here before we get started. This is only 850 cc's worth of dilute acid here. So I didn't think that was enough. So I went down to the auto parts store and I bought another one. I just love the warning graphic on that. That's great. I love that. The hand dissolving in acid. I love that. And I'll tell you what, I bought this one online from Amazon. And there'll be links in the video description to everything I use here today. So I bought this one online at Amazon. I went down to my local auto parts store and I got this one. And, well, it's actually a little bit more acid. And it was only about half the cost of this. And I didn't have to wait for ground shipping to bring it to me. So, yeah. So there we go. So now we've got plenty of acid. Between these two, we've got almost 2 liters of dilute acid. We should be able to concentrate these down to a fair amount of concentrated acid. So, yeah, a few hundred milliliters of concentrated acid anyway. That'd be enough to make some concentrated nitric acid with, I think. So, and hey, if it's not, I know exactly where I can go to get another one of these inexpensively. The AutoZone. Right up the street from me. They carry this in stock. So, yeah. All right, and then another thing, we're going to need to know exactly how concentrated our acid is getting as we're boiling it down. Well, I've got this handy-dandy chart here that tells me density at a given temperature versus concentration. So you can find this on the internet. Just Google sulfuric acid density versus concentration, and you can find a chart like this easy enough. Adjusting for temperature, we should get a pretty accurate idea of just how just how concentrated our acid is. So we'll measure this when we get started. I will combine these two, and we'll measure what we've got before we start. They should be somewhere between 35 and 40% concentrated, and then as we concentrate it, we'll measure the density again and see if we can figure out just what we can concentrate this stuff up to. I'm hoping 95% or better. We are lucky that it's unlike nitric acid, sulfuric doesn't form an azeotrope with water. So you can just keep concentrating it over time. But it does get to the point, this stuff likes to hold on to water so much it does get to a point where you're boiling off a lot of acid to try and remove that last little bit of water. So again, you reach a point of diminishing returns eventually, but you can produce very concentrated acid this way, whereas you can't do that with nitric acid. Although there are tricks. I will show you how to get concentrated nitric acid. Basically, don't start with any water in your reactants, and you don't have to worry about a water azeotrope forming. But we'll get to that in another video. Okay, so let me get started dealing with this stuff. We'll get it opened up and poured into a beaker, and we will get started. Well, we'll measure the concentration initially. We'll get started boiling it down and see what happens. All right, so let's get these into the beaker. And then we'll measure the density of the combined liquids. Now that cute little infographic of the dissolving hand, whoa, yeah, you see I'm splattering it a little bit, I'm standing way back. It's not just there for cuteness. This stuff is very dangerous. You don't want to get it on your skin, especially if it's hot. And especially if it's hot and concentrated, which is what we're going to do. We're going to heat this stuff up and try to concentrate it. So yeah, you don't want to get this on your skin. It will burn. It will char your skin. I'm not sure exactly what kind of a lid we've got here. I've never seen one of these before. I guess the idea probably is that I guess you cut this off and squeeze it out through the little tube they give you. We'll try that. That's not coming off. Alright. So yeah, this stuff is very dangerous, especially once it's hot and once it's concentrated. Of course, even in this form, it will give you nasty burns. It will blind you if you get it in your eyes. So you have to be careful. Gloves, eye protection at the very least. And I will clean up that mess I made over there with the splattering before we get too much further along, so I don't forget it's there. Maybe put my hand in it, ungloved or something, you know? Accidents like that can happen. Okay, so let me clean this up, and then we'll measure the density of this stuff to start with. Alrighty, so let's get the density of this stuff measured, and then we'll know the percent concentration it is based on this chart right here and the temperature. So let me put 100 milliliters of this in this graduated cylinder, which I know what the weight of the cylinder is because I have it written on it. Okay, right down here. Don't forget to weigh your cylinder before you do this, or tear your scale with the cylinder on it. You bring this right up to the 100 milliliter line because that's going to make the math real easy. Alright, there's 100 milliliters right there. Get where you can see it. Hopefully you can see it. Now this is not my most accurate scale, but my most accurate scale won't handle the weight of this. It only goes up to 200 grams. We are at 264 grams. Okay? So if we subtract 139 grams from that, (264) minus 139. I'm rounding a little bit because this thing doesn't go, you know, to as great a accuracy as my other one does. So we are at 125 grams of acid in there. So we divide that by 100, we're at 1.25 grams per cc. What's our temperature? Temperature's right at 30C. Okay, so we're on the 30C line here. We want 1.25. And what do you know? Right about 35%. Exactly what I was expecting this to be. That's about what they sell this stuff as, 35% for batteries. So, okay. So let's see if we can concentrate this up to something significantly more potent. We are at right about maybe 1,850 milliliters. So we evaporate this down to around the 600 area, we should be getting pretty close to 100% strength. We'll see. So let's put this on the hot plate and get started. Okay, so here we are in the fume hood. Gonna turn the heat on, get this hot, and we will should just boil off as much of the water as we can, and we'll see how long this takes. I'm thinking it's going to take quite a while. There's a lot of water there that needs to be boiled off. And I'm not actually going to get it up to a fast boil because I don't want it spattering all over the inside of my fume hood. So we're just going to get it good and hot so that we're losing a lot of water in the form of steam. We'll probably have to crank the temperature up as we get this more and more concentrated just to continue to drive off the water. But for now, I don't want it too much, I want it right around 100C. I don't want to really put spurs to it right now, just so I don't spatter it. So anyway, we're up and running, but this is going to take a while. I'll give you updates from time to time as we go. It's about an hour later, and this is heated up. We've got some very soft, quiet boiling going on. This is great. Looks like we've lost almost 100 milliliters of liquid already, just evaporating gently as steam, so perfect. So we'll just let this go and let it continue. I may shut it down overnight rather than leave it on overnight because I don't want anything crazy to happen when I'm not here to monitor it. But we'll let it go for at least a few more hours today until it gets late in the afternoon, and then maybe I'll shut it down and pick up again tomorrow. But I'd say this is going perfectly. We're boiling off the water and concentrating the acid, just like we want to. All right, I'll give you another update soon. Well, it's about, I don't know, hour and a half later, maybe closer to 2 hours, and look at this. We're down to about 1,300 milliliters, so we've lost about half a liter of water already out of this. We are really concentrating the heck out of this acid. This is going good. Just quietly boiling away, but let me show you this. 120C. So the liquid is actually quite a ways above the boiling point of water, and it's just very quietly, bubbling gently over there. The acid, the sulfuric acid has a much higher boiling point than water, and as we concentrate this, the temperature, which we'll have to get this up to boil the water out, is going to go up and up, and pretty soon we'll start getting white fumes out of it, and we'll actually start vaporizing some of the acid. So it's got to get a little more concentrated before we see a lot of that, but we're getting there. So it's getting late in the day. I'm going to let this go for a little while longer, and then turn it off for the night, and we'll pick up tomorrow with boiling it off. One thing I am a little worried about is the weather's supposed to be very rainy for the next few days, very humid. Hopefully that won't inhibit boiling this down. I don't have any control over the weather, and I don't want to wait until it gets better in a few days to finish this project. So we'll see how it goes. Hopefully we can still get this down to 95% or stronger acid and get it bottled up before the humidity dilutes it again. We'll see. Anyway, just going to let this keep going for now until it's just, time to shut it down for the night. I'll cover it up and we'll pick up tomorrow. All right, it is the next day. Getting kind of a late start today because it rained cats and dogs all morning. But yeah, we got down a little below the 1 liter mark yesterday. So we are cranking on this. Let me pull this out and set up to measure the density on it again, and we'll see what concentration we're at now before we start boiling it down again. Okay, let's see what we've done here with this first few hours of boiling. See what the concentration's up to. Seems more viscous, more oily. There we go. Right. Ah, the wrong units. 286 grams. All right. Let's see here. See if I can do this with my glove on. 286 minus 139 equals 147, which divided by 100 is 1.47. So, I got to measure the temperature too. Forgot about that. The temperature 29, so we're probably still good going on the 30 degrees C line, but we're going to have to go to the next page. We've increased the density on this stuff. All right. So if we stay on the 30 degrees C line, which one of these is 30 degrees C now? Looks like this one right here. Yeah. So 1.47. We're right about 58%. 58%. So we have increased the density of this stuff and the concentration, something wonderful. Make sure I don't pour this on my phone. That would be bad. Yeah. So we've gone from 35% up to 58%. Not too shabby. Not too shabby. So let's get this back in the fume hood and keep the good times rolling. Let's see if we can concentrate this some more today. So there we are, back on the heat. And we'll see what the level gets to before I have to shut it down tonight. Now, this has taken me a couple of days to do this, but, it's because I'm not letting it run overnight, and there was a rain delay this morning, so, if you're doing this at home, you could probably do it a lot quicker than I am, but, through the magic of YouTube, it's all going to be edited together for you into just a few minutes. Lucky you. All right, we'll be back when we've concentrated this down some more. All right, so it's a couple hours later, and we are down to about 700 milliliters. So this is evaporating down nicely. We don't really have any kind of serious boiling going on anymore, but there is a lot of white mist coming out. And I think what we're getting now is we're actually starting to boil off some of the acid. I don't know how well it's showing up, but it's just sort of boiling off the surface down there, or evaporating from the surface. So I think we're probably losing some acid along with the water now, this white mist. Let's take a quick check of the temperature that's going on in here. Yeah, like 176 C. So yeah, we are well above the boiling point of water. So yeah, we're starting to evaporate off a lot of the acid, but that's just something you got to do to get the last of the water out. And I don't think we'll ever get it down to pure acid, but you know, we can get it pretty darn concentrated. So I'm going to let this go a little while longer, at least down to the 600 milliliter mark or below, and then we'll see what we've got. So it's late afternoon again, but we got a couple more hours before I have to shut this down, and we'll see what we got once it cools off, just how strong the acid is. Well, look at this. We are just below the 600 milliliter line, and we've got some significant fuming going on in there. That is no longer steam for sure. So let's see if we get a quick read on the temperature without breathing any of this stuff. Oh yeah, 213 C. So yeah, we are getting up there, and really boiled this down a lot. I'm going to turn the heat off and wait until this stuff stops fuming so bad. And I'm going to cover it, probably with some cling wrap to keep moisture out because it's very humid out here. And I think we've got to the point where this will probably start absorbing moisture out of the air. We've got it so concentrated. And once it cools down, probably tomorrow morning, we'll check the density on it again and see just where we are with that. Hopefully, we are pretty close. Well, there, it's cooled down enough that it stopped fuming and I can get some cling wrap on it. And we are right at about 500 milliliters. So once this cools down to ambient, which I'll wait till tomorrow, not so worried about it now that the moist air can't get to it. And we'll measure it and see what the strength on it is. All right, it's the next day. This has had a chance to cool down. And in fact, cool down. It's cool out here. This is the first cool morning I remember in a long time. I guess finally here at the end of September, the last couple days of September, the never-ending infernal hellscape is the Florida summer is finally loosening its grip on us, and fall's trying to sneak in. So let's see what the temperature is here. Yeah, 25, so a little bit cooler than usual around here. It'd be closer to 30 by now and on its way up this early in the morning normally. Okay. So yeah, we're just right around 500 milliliters left in the beaker here. And I don't know if that's showing up or not, but not only have we reduced the volume on this stuff, but the color's gone a little off too. I imagine as we're concentrating the acid, we're also concentrating whatever minor impurities were in it. Let me dispose of this so it's not laying around. Yeah, that cling wrap had concentrated acid on it. Not something you want to leave laying around just anywhere. So let's see just what our concentration is. I'll tell you what, this stuff feels dense and viscous and oily. Let me tell you, it's thick. Yeah. Are we there yet? The eternal question of road trips, but I don't know. I guess we'll find out here just how close we are to having concentrated acid. Now, I said in the beginning that this stuff doesn't form an azeotrope like nitric acid does, and that's not quite true. Once you get up to like 98.5%, it does form an azeotrope, and you really can't get it any better than that. But 98.5% is pretty darn concentrated. That's pretty much going to work for any of my needs. So let's see just what we've got here. $314 grams. Notice how much heavier it gets every time we do this. The same volume of liquid gets a lot heavier. So let's see, 314 minus 139 equals 175 grams of acid there. So divided by 100 is 1.75. So 1.75 grams per cc at 25C. We're only up to 83%. So we've got to do some more boiling on this stuff. Yeah, I was thinking we probably weren't going to be there yet. So got to put this back in the fume hood and boil it some more. And we are going to lose some acid along the way, unfortunately. But that's just the way the cookie crumbles when you're doing this. In the end, I'm hoping we'll have at least a couple of 100 milliliters of fairly concentrated acid left. And hey, hopefully this cool weather will mean a little lower humidity too, so that would be nice. That would help with this process of concentrating the acid, because um, concentrated sulfuric acid likes to do nothing better than pull moisture out of anything it touches, including the air. So let me put a little of this on this paper towel and see if we're getting strong enough yet to char the paper towel. Yeah? Oh yeah. It's getting it's strong enough to char the paper towel. Yeah. So that's what it'll do to your skin if you get it on you when it's this potent. So, be careful. It will just char your skin something awful. Okay. So let me get this back in the fume hood and continue cooking it. Yeah, so here's a close-up of what our 83% acid did. I mean, that's as near as I can figure what the strength is. So, wow. Yeah, getting potent. Okay, this is back on the heat in the fume hood. I'm going to go without the Corningware dish, which I always feel like is performing acrobatics without a net. Just in case the beaker were to crack, we'd have concentrated sulfuric acid going all over the place. But I think we're going to need to get this stuff pretty darn hot to finish the reaction here. And the Corningware dish kind of spreads the heat, and it doesn't. The stuff in it doesn't get as hot as it needs to sometimes if you need it to get really hot. So we're going to go straight on the burner, and we'll see how this works, and see if we can concentrate this some more. So a little bit of a warning to you, lesson learned here. Um, After yesterday, everything in the fume hood has a film of sulfuric acid on it. It's condensed out of those white vapors that were coming out of here. Everything. So I'm going to have to clean everything inside the fume hood once this is done. I'm going to wait until after we're done with this project, so I only have to do it once. Um, yeah, fortunately, most of it's plastic and glass. It's not going to be bothered by it too much. I'm not so sure about my hot plate. This may accelerate its demise. They don't tend to last too long for me. Anyway, also the blower on the fume hood did not want to start today. So I took the hose off on the back and looked inside, and there's a nice puddle of condensed sulfuric acid in there, and the blower was seized up. I gave it a spin with a screwdriver and freed it up, and it started up, fortunately. But I don't think it's going to survive this process either. I have a spare blower, so once we're done concentrating this stuff, I will change out to a new blower carefully so that I don't dump concentrated sulfuric acid all over myself out of it. But yeah, this is kind of a destructive process, what we're doing here. The concentrated sulfuric acid will pretty much destroy anything it touches, including you, so be careful. So, all right, so this is heating up. We'll see if we can get this done today, or at least as done as I think I can get it. I mean, it's quite possible that this acid is already strong enough for pretty much anything I want to do. We'll see if we can strengthen it a little more. I'll also work on ways to measure the strength of the acid a little more accurately. Um, with this scale over here, I'm really limited on just how accurate I can measure the strength of the acid. Once we get above 90%, the difference between like 90% and 98% is pretty darn small in the density. So I'll see if I can come up with a better way of measuring it more accurately, so we can hopefully know exactly what strength our acid is. Okay, so we're just going to let this cook for a while and continue ruining the fume hood. Well, that didn't take but a few minutes to heat up without the Corningware dish under it, between it and the burner. So we are back to furiously fuming there. I'm going to let this go until we get below the 400 milliliter mark down there, okay? And then I think I will call it. We'll let it cool down and test the density on it again and see exactly where we're getting, because I'm not confident I can get this, all the way to like 98% where the azeotrope is. But we'll see just how close I can get it. From how badly it charred that paper towel, I'm thinking this is already pretty potent acid, and it may be stronger than I think it is. So we'll try a slightly different method to measure the density the next time we measure it. But I'm going to wait till it gets below the 400 mark. Might as well. I'm ruining everything already. Might as well just let it go and see what we get to. So at the rate it was boiling down yesterday, this probably won't take too long. So I'll keep an eye on it. I have something I need to do later this afternoon, but I can let it run for a couple hours, and I'll bet by then we'll be there. So let it cook, and hopefully nothing will happen to the beaker. Okay, so I turned the heat off on this and lit it up, and it's cooling down. The amount of fuming was just getting outrageous, absolutely outrageous. And it was really just coming in a solid stream out the exhaust of the fume hood. It was leaking out around the doors. It was just getting to be, an unhealthy situation. So I shut it down. So it didn't boil off that much. But on the other hand, this acid is apparently stronger than I thought it was. So maybe we're okay. I'm going to let this cool down the rest of the way, and I'm going to cover it over again with some cling wrap to keep the humidity out of it until I can get a good measurement on just how strong it is. I have ordered a smaller graduated cylinder with overnight delivery that I can do a measurement on this with, and it should be able to use it with my smaller, more accurate scale. So we'll see. I mean, if this is up in the 90s somewhere, I'm going to say it's probably close enough for my purposes. Pretty much anything I want to do with it, and probably pretty much anything you guys want to do with it. There are other ways to dry out acid besides boiling it, and hey, maybe in a future video we can explore those. But I think this is probably about as strong as it's going to get. So let me get it covered up and let it cool down, and we'll see where we are once my new graduated cylinder arrives. Okay, so I've got my 10 milliliter graduated cylinder here. It's much lighter, smaller, and hopefully we can get a much more accurate measurement of the density of this stuff in here, because if you look on the chart here, the difference in density between, say, 90% and 95%, there's not much difference there. So we need to measure much more accurately to figure out just where we are with the strength of this stuff. So let me figure out what my new graduated cylinder weighs. 8.21 grams. All right, so 8.21 grams. Let me write this on here. Yeah, 8.21. Okay. Now we shall measure the density of 10 milliliters of this stuff. And then, I'm using 10 milliliters here to keep the math simple. Got a lot of bubbles in there. That might throw me off a bit. Why so many bubbles? Uh-oh. I'm also making a bit of a mess with the acid here. That's not good. All right, let's see if those bubbles pop while I clean up the drips I've made here. And hopefully we can get a nice accurate measurement. Okay, this just isn't working. You start over again here. Bubbles! Bubbles are my nemesis here. I keep getting a lot of bubbles in this, and bubbles, well, they're areas of low density. So they're going to throw my density calculations off. But I think, you see there's a bubble right in there. Get it to pop. Ah, good, I popped it. I think if I put the acid in very slowly, running it down the side, and I don't try to get the last little bit in, because that's where I blow bubbles really bad, is trying to put the last little bit of acid in here. Yeah, okay. Okay. It just takes a little bit of extra time, a little bit of extra care. And we can get acid in here without a lot of bubbles. Okay. Maybe. Yeah. Ah, there goes some bubbles. Okay. Just can't seem to get it bubble free. Let me see if I can suck those bubbles out of there. That would be nice. Yeah, okay, I got rid of those bubbles. The last couple milliliters in here without bubbles. Let's see here. Uh-oh. Yeah, I'm getting it all over the place. Clean that up. You see, I've got a bit too much acid in there. Let me suck a little bit out. Now I've got a bit too little. Get the meniscus in just the right place. That looks pretty good. All right, let me clean up my mess here before anything bad happens. Well, if nothing else, this stuff's a pretty good paint remover, let me tell you. Ooh, chewing holes in my rag. Wow. Okay, let's get a weight on this stuff. 26.1. Yeah, it's all dancing around all over the place. A little bit of wind. We'll go with 26.09. That looks pretty stable. So 26.09 minus 8.21 equals 17.88, or 1.788 divided by the 10 milliliters in there. So that's saying we're somewhere between 84 and 85% strength. We may have gone backwards a little bit because this has sat around for a couple days before I could get this measurement done. So it may have absorbed some moisture from the air. It's probably doing that right now. I've got the cling wrap off of it. But still, this is this is some pretty potent stuff. Whatever the actual, look at that, strength is. Look at it char that paper. Yeah, it's like a scene from Alien, man. It's going through the first layer and going through the second layer, and oh yeah, it's starting to work on the third layer down there. It's just chewing its way through this stuff. Let me dump this out here before I spill it. So we'll talk about other ways to concentrate this acid, because I think this is probably strong enough for my purposes. The way it's charring the paper over here, I think it's definitely Probably strong enough for my purposes. But yeah, look at that. Through four different layers of paper, and it's still going. So yeah, but there are ways to further concentrate this. Let me get the cling wrap back on it here so it doesn't get any weaker. And we'll talk about those ways to further concentrate this acid in later on in this episode. Okay, so let me clean up my mess here, and maybe we'll work on a way to test. Well, we know what percentage of acid we have here, but how reactive is it? That's a good question. Maybe we can test it and see just how reactive it is with a classic test of concentrated sulfuric acid. So let me get set up for that, clean up my mess here, and we'll test it. Well, if nothing else, I've developed a fairly effective paint remover. Everywhere I got a little bit of the acid on the bench top, the paint is gone. So it's fairly potent in that way. Let me get rid of this. Okay, so what I've got here is just some ordinary table sugar, like you put in your tea or your coffee. I got about up to the 50 milliliter mark in this beaker in it, and I'm gonna put some of this acid in there. Decant off a bit here. We're gonna talk storage options for this stuff in a minute too. Let's see, how much is that? Yeah, I probably don't want to use that much. And I have warmed this Corningware dish a little bit just to try and speed up this reaction because it can be quite slow. But stir this up. Oh, yeah. Look at the color change. It's gone black. Oh, yeah. Look at this. Look at this. Oh, yeah. There's our black carbon snake forming before your very eyes. This is usually a very slow process. But holy cow. Look at that. And I'm standing back out of the fumes. There's a lot of steam there, but a little bit of sulfuric acid fumes too. Okay. So I would say our acid is strong enough for my purposes. That's some stiff foam there. I would say it's strong enough for my purposes. I think I can make some pretty darn decent nitric acid with this stuff. The first bit that comes over will have a little bit of water vapor in it, but that's the way it always is when I make my own nitric acid. It's kind of like when you're distilling whiskey. You got your heads, your middlings, and your tail, and you always get rid of the heads. Well, it's the same when you're making nitric acid. You just discard the first bit that comes over, and then you get the stuff in the middle of that. That's the good stuff. Okay. Excellent. Well, I would say our concentrated sulfuric acid production has been a pretty good success. Didn't quite get it up to the strength I was hoping, but still, I think it's more than strong. Wow, that's still wicked hot. Okay. Wow, that's one heck of a reaction. That is super hot still, even though it's been a few minutes. Okay, so storage options for your acid. Now that you've made some concentrated acid, what are you going to store it in? Well, I've been saving my empty bottles that I buy my acid in. And they're perfect containers for it because, they had concentrated sulfuric acid in them. They can obviously handle it. But I'll give you a close-up look at what this container is made of, and you could probably find something in your area that will work just as well, okay? So let's take a close-up look at this. All right, do you see that 2 on there and HDPE below it? High-density polyethylene. So this is the kind of container you want to use to hold your acid. This is the kind of container my concentrated acid comes in when I buy it from the store. So it can obviously handle concentrated sulfuric acid. So look for that 2 and HDPE, and your container should be able to handle the acid. Now glass works too, but remember, glass is fragile. It breaks. And you don't want to spill your acid all over the place. That could be bad. So, okay, we can put our acid in high-density polyethylene containers. So that's what I'm going to do. I'm going to put this in here. And and we will keep it for future use. Excellent. So we got just a bit over 400 milliliters of very strong concentrated sulfuric acid here. This stuff is viscous and oily. It just doesn't want to come out. A lot thicker than water, let me tell you. All right, I'll just sacrifice what's left in here when I clean the beaker out. All right, there you go. There's your storage options. So I made a mistake earlier. Did any of you catch it? Any of you catch it at all? See what I did wrong? I forgot to measure the temperature of the acid when I measured its density. I was looking over here like on the 20C line. Let's see what we actually got, because it's a bit warmer out here than that. A 28. So we're probably best off using the 30C line. So 17.88 is what we came up with. Okay, that makes a big difference. We are between 87 and 88% strength. Yeah. So really, we really haven't lost much strength. I was guessing it was more like 88% strength after my last measurement. So the last little bit of boiling didn't accomplish much, or if it did, we got some water back in it because it sat around a couple of days since then. So, okay. Anyway, we'll call it 88%, and I think that is going to be strong enough for my purposes. And like I said, we'll talk about some other ways that you can concentrate this stuff if you need it stronger. All right, once you get it bottled up, label what you've got in it so you remember, so anybody else messing around in your workshop knows what it is. Maybe put a little danger sign on it, maybe skull and crossbones, something. Get artistic. Make sure people don't mess around with it because this stuff is very dangerous. Also, one more word about storage containers. Find the sturdiest one you can. A lot of high-density polyethylene containers are very thin and fragile. These acid containers are very thick, sturdy plastic. So they don't want these breaking accidentally and spilling the contents everywhere. So find the sturdiest one you can to store your acid in. So I think I mentioned earlier that there's a couple of other ways to concentrate sulfuric acid besides just boiling it out in the open air like I was doing, well, in my fume hood, and producing outrageous amounts of sulfuric acid fumes. So a couple other ways. The most obvious one is distillation. If you have the distillation apparatus, you got a boiling flask, a condenser, a receiving flask, preferably with ground glass fittings. Yeah, you can distill it, and you should be able to get it up to about 98% concentration if you're careful. And that's the most obvious, probably easiest, most approachable way. Another way is if you want to go to the trouble of synthesizing sulfur trioxide, which some amateurs, I've seen some amateurs do that. It's not that difficult, apparently. I haven't tried it yet, so, everybody makes it look easy on YouTube. But yeah, if you can make sulfur trioxide, you can bubble the sulfur trioxide gas through your dilute acid, and it will react with the water in it to produce sulfuric acid. And over time, it gets more and more concentrated as the water gets used up. So that's another way to concentrate the acid. Or, if you don't mind lots of fumes, you can just keep boiling it down and probably get it, at least a little stronger than I have it here. But I think this will work for my purposes in the next video. Well, there you go. Now we've got two pieces of the puzzle done. We've got our potassium nitrate made from commonly available materials pretty much everywhere. We've got our concentrated sulfuric acid made from battery acid, which should be available pretty much everywhere. And like I said, there are other ways to get to dilute sulfuric acid, which you can then boil and concentrate up to concentrated sulfuric acid. We might explore some of those other methods in future videos just for the fun of it. But as long as the battery acid's available, that's a good place to start because it's already like 35% concentration. So we got two pieces of the puzzle. And with these, in a future video, we can make concentrated nitric acid. Okay, so watch for that video down the road. It may be a little while down the road because I've got to go out of town in a couple of days for a while. But when I get back, we'll get the apparatus out for making nitric acid. Until then, you can watch some of my older nitric acid making videos. I'll put a link in the upper right if you just can't wait. And when I get back, we'll set up the apparatus and we'll make ourselves some nice homemade nitric acid using our homemade potassium nitrate and our homemade concentrated sulfuric acid. So subscribe to see that future video and all my other future videos that are coming out. And thanks a lot for watching this one. Check out my two other channels, Electric Geek 64 and Mike's Lapidarian Fossils. And I will see you in the next video. Thanks a lot for watching this one. Bye. Oh my God, have I got a mess of concentrated acid contaminated equipment to wash up over here. Yeesh. Try not to get any of it on me. Okay. See you in the next video. Thanks for watching. Bye.